In this episode, we see how to use AWS S3 in Elixir and with the help of library ExAws. We start by setting up an AWS account and credentials. Then we configure an Elixir application and see the basic operations, upload and download with small files. Then we see how to deal with large files, making multipart uploads and using presigned URLs to create a download stream to process data on the fly. If you don't have an Amazon Web Services account yet, you can create a new account at awsamazon.com and use the free tier for the first 12 months, where you can use up to 5 gigabytes of S3 storage for free. Be sure you check all the limits, like the number of GET requests and PUT requests, before start using the service or any services in AWS. And take always a look at the billing page, where you see how much you're spending, and you can keep track of the usage of the free tier. To access to the S3 resources, we need at first to create user with limited permissions. So we go into My Security Credentials, under Users, and we click Add User. So here we create our user, like Poetic Coding, Elixir Test. And we select only the programmatic access type. In this way, this user will not have a password to enter in the management console. Then we set the permissions, attaching the Amazon S3 full access policy, limiting the user to just the S3 service. Now, this policy is fine for this demo, but it's still too broad, since with these credentials, a user or an app can access to all the buckets, files, and configurations of S3. By creating a custom policy, we can limit the user permissions to just the S3 actions and buckets that are really needed. And you can find more on this on this page. You find the link in the description of this video. And then we review and create the user. Once the user is created, we can download the access key and secret key. We can download the CSV with both keys, or just copy and paste the keys from here. But we must keep both keys secure, because whoever has these keys can access to our AWS S3 resources. And let's create an S3 bucket using the management console. So we just need to do create bucket, and let's call it Poetic Coding AWS Elixir, and next. Be sure we block all the public access. We review the bucket and we create it. So now let's create a new application. I call it Cloud. And first, let's add the dependencies. So this is the library ExAws, and this is the library to get S3 functionalities. The library uses by default Acne to make HTTP requests to AWS. Then we create a config folder with a config file. So we import config and we configure ExAws. So at first, you see we've added JSON. So I want to use JSON as a JSON codec. By default, ExAws uses Poison. So if I want to use a different JSON codec, I can set it here. Then we set the access key ID and we pass a tuple. So in this way, we load the key from the AWS access key ID environment variable. And we do the same for the secret access key. So first, let's get the dependencies. Then let's compile the dependencies and the project. Then be sure to load the environment variables, the access key ID and the secret access key. In my case, I have them in this end file. And then let's run the interactive Elixir. At first, we want to list the buckets available. So we have this module, the EX AWS S3, and the function list buckets. But this function doesn't make the request itself, returns an operation S3 struct. So to make the request, we use the EX AWS request function. So this actually makes the request, returning inside the body the information we want, the buckets list. So if we want just this list, we can use the get in body buckets, and we get just our list. Great. We want to see now how to do basic operations like put an object, list a bucket, get an object, and delete an object. So let's consider this small file. It's around 30 kilobytes. It's an Elixir logo. And we load the content into a local image. So file read elixir logo.png. So all the file content is loaded into memory. And then we use this function to create an operation, put object. The first argument is the bucket name. So poetic coding, AWS Elixir. The second argument is the key, the object key, which is the path in S3 in the bucket. Images, Elixir logo.png, and then the file content, so local image. And as you can see, it returns an operation. So we want to make a request, EX AW, like before, request. And it returns a status code 200. So if we go inside the bucket, we see now images and elixir logo.png. So it was uploaded correctly. And let's list the objects in the bucket. So AWS S3, list objects and the bucket name. So this is the operation. So EX AWS request. And it returns a response with the contents body. So we can do get in body contents to get just what we need, and we see that we have one object. So how to get the content of this object, of this file? So let's use EX AWS S3 get object. So the first argument is, as always, the bucket name. Second is the key. And then we pipe it into EX AWS request with a bang. So our response has a body with the full file's content. So we can save into S3 file, PNG, the response body, and see that is our logo. And to delete this file, we just need the S3 delete object. So as always, so the first argument is the bucket name, the second is the object key. This is the operation, so we pipe it in the request function. we have a status code 204, and if we refresh here, we see that the bucket is now empty. This image is about 30 kilobytes, and we can simply use putObject and getObject functions to upload and download it. But there are some limits. With these two functions, the data is fully kept in memory for both upload and download. putObject uploads the file in a single operation, and we can upload the objects up to 5 gigabytes in size. S3 and ExAWS library support multipart uploads. This means that a file is divided into parts, by default 5 megabyte parts, which are sent separately and in parallel to S3. In case the upload of a single part fails, ExAWS retries just the upload of that 5 megabyte part. With multipart uploads, ExAWS uses file streams, avoiding to keep in memory the whole file, and we can use a multipart upload for objects from 5 megabytes to 5 terabytes. So let's consider a file we've used in this article. You find it at this link, and it's a 125 megabyte text file. This file has a number, an integer in each line, and the idea is to sum all the numbers and get the result without having to load all the file into memory. So we just want to process it on the fly. So let's first download it. Let's see that inside the files, each line has an integer. Before trying to make a multipart upload, let's add a debug request through option in the configuration so we can have some log on the terminal during the upload. And then we go on the terminal, go start the interactive Elixir, and instead of loading all the content, which is around 125 megabytes, into memory, we use a file stream. So we use the S3 upload module stream file and the path numbers.txt, which returns a file stream, and we pipe it into S3 upload function, which so the first argument is of this function is the file stream. The second is the bucket name, so Poetic Coding, AWS Elixir. The third argument is the key, numbers.txt. And then we make the request. And you can see there are many parts. So you see here part number 2, part number 3, all in parallel, and it fails. So why does it fail? I've simulated a slow connection. So in this case, there is a timeout of 30 seconds per part. So to extend this, we can pass a timeout option to the upload function. Let's see again. So the file stream, and here in the option, we pass a fourth argument, a keyword list with timeout, let's say 120 seconds. And this is passed to this function. And then we make the request. And we get a response with a status code 200, which means that we've successfully uploaded the file. So we first delete the numbers.txt file, and then we want to download the numbers.txt back from S3. But to download a large file, it's better to avoid the getObject function, this one, because it holds the whole file content in memory. Instead, we can use download file that downloads the data in chunks, saving them directly into a file. So the first argument is the bucket name, Poetic Coding, AWS Elixir. And the second is the object key, numbers.txt. And the third is the file, the local file where we want to store the data. And we want to make the request. And it's downloaded correctly. Unfortunately, we can't use this download file function to get a download stream and process the file on the fly. However, we can generate a presigned URL to get a unique and temporary URL, which we can use to download the file with a library like Mint or HTTPoison. So the function is AWS S3 presigned URL. So the first argument, it wants AWS config new, so this S3. So this passes as a first argument the configuration we've set in the config file. Then the action get, then the bucket name, Poetic Coding, AWS Elixir, and then the object name, numbers.txt. And we get our link. So in this case, we see that expires in an hour. If we want to change the expires time, we can pass an option as a fifth argument, expires in, and we can say in seconds, 300 seconds. And you see here that this parameter is changed. And we can use this URL to download our data. Again, you can see in this article how to create a stream from an HTTP response to process the response on the fly. And from here, we can take the code. There is an HTTP. Here is absolutely not production ready, but we can take this and create HTTP stream access. So we have two functions here, get, which uses HTTPoison. So we need to add HTTPoison. The version now is 1.6. Then we get the dependencies. So what it does, it creates a stream. So we get a stream of chunks, and lines transforms a stream of chunks to a stream of lines. The idea is to now get a presigned URL, use this module to download it and process it on the fly. So we want to sum the numbers we have in numbers.txt. So at first we want to generate the presigned URL. Presigned URL get Poetic Coding, AWS Elixir, and the object is numbers.txt. Then we receive here an OK and the URL. So we do something like this to just return the URL to maintain the this pipeline form. And then we use this HTTP stream module get. So the URL goes here, and we convert the HTTP stream of chunks to a stream of lines, and then we convert each line to an integer. So stream map. So we have line, each element is a line, case integer, parse line do. So in case there is a number, we just return the number, the integer, and if there is an error, we just return 0. And then we just want to sum all the numbers, all the integers, and then we print the result. And here, sorry, URL is missing. Okay, URL. And let's start the observer to see if we have memory spikes. So we start from 36 megabyte, and we do cloud start. So it allocates the megabytes. So we see that we are downloading 125 megabytes and it's not loaded fully into memory, and we get our result. As always, if you have any question or feedback, please let me know dropping a comment below. If you want to be updated when new content is available, subscribe to this channel and to the Poetic Coding newsletter. Thanks for watching.